So all of these have the same factors. They just have different numbers of the factors, and some of them have different coefficients, things like that. And they will have a different degree as we go through this. So on number 1, what's the degree of number 1? 6, because of 3, 4, 5, 6. It was even nice and put the ones on the one you didn't need it on. Then the degree of the second one? 4. The degree of the third one? 7. This one? 7 and 7. Okay. All right. So the different degrees, same factors. So then let's talk about behavior. Do any of these have a negative coefficient? No. Okay. So we're just really looking at positive. I'm sorry, not positive, but even and odd. So if we have an even degree, then our end behavior looks like this, right? Which means that 4 has to also look like this. And then odd positive, think of a cubic, and it looks like this. So that's true for all of them because they're all 7 and they're all positive. Okay, so even though these all have the same factors, the same zeros even, the graphs aren't all going to look the same because some of them are odd, some of them are even, and they have different degrees and different all kinds of other stuff. So then we have to go and find the Y-intercepts, which some of y'all are getting some weird answers on some of those. Let's make sure we know how to find the Y-intercept. The Y-intercept is what you get when x is 0. So if x is 0, then I take 2 to the third power, what's that? 8 times a negative 1, so negative 8, times a negative 3 squared. What's negative 3 squared? 9. So if you need to kind of write it down as you go, so that's a negative 8 times a positive 9 gives you what? 72, positive or negative? Negative. Okay, so 0, negative 72. Okay. Then we come here. I got to use that 2. 2 times 2 is 4. Negative 1 squared is just 1. So that's just 4 times 1, that's 4. Times a negative 3 is what? Is that 4? Negative 12? All right. Then 2 to the 5th power. 32. I'll write that one down. Times a negative 1 times a negative 3. So it's going to be a positive what? 96. 0. So then I have to do 5 times 2 times negative 1 to the 4th power is what? 1 times negative 3 squared is 9. What does that give me? 90. 0, 90. Then 2 cubed is 8 times a negative 1 squared is just 1 times negative 3 squared is 9. So you get 0, 72. Everybody understands how to get those, right? Quickly? Good? All right. So now then we're going to look at what happens at each root. Okay, I don't like this whole wiggles thing. That's kind of not right. What does it really mean by wiggle, do you think? Because you have a wiggle, it crosses, or it's tangent to it. So as far as what happens when we were sketching these, what do you think the wiggle is? Close. It's the curvy thing. What's the curvy thing? Point of inflection. Because the bounce is actually the one that's tangent to it. If you think about what tangent means, that makes sense? It would make it tangent to the x. So wiggles, that's not a very good thing. This is a point of inflection. We're going to write it out right here, but we won't write it out every time, just to make sure we know what it's talking about. Flexion. It crosses the axis, that makes sense. Or it's tangent. And saying tangent is fine because that's good, but that's a bounce too. So really tangent is more official than bounce, but I think maybe that might help you a little bit better. All right, so when the 0 is negative 2, what happens at the axis, since that's the power of 3? It's the point of inflection, right? So we'll just put POI for point of inflection. Everybody okay with that? It's less writing. It's less writing than wiggles, too. All right, so at when x equals 1, what happens on the graph? It crosses. Okay. And then when x equals 3, what happens? It bounces. Okay, everybody good with that? Okay, so you go through and you fill in the rest of that chart, and then we'll look at graphing. This is what I got for my first column. Do we all agree with that? Point of inflection, crosses, point of inflection, crosses, point of inflection. Okay. So then for the second one, it crosses, and then what? Bounce. Then what? Cross. Then bounce. Then bounce. Okay, and then on the third one, it's a bounce, and then what? Cross. Then cross. Then what? Bounce. And then bounce. Okay. All right, so we use all that information to be able to come and graph them. Now, one of the things I took off for on your homework that I gave you back was not labeling the values on the axis, like the -2, the 1, like literally writing the numbers. Even though I did take off for that and you need to do that, I'm not going to write them up here because my pen's thick and then it makes my graph look bad. I want to make sure you can see your graph. But and another kind of small on yours too. But you should always make sure the numbers are actually labeled on there. So the other thing I need besides, it's the same intercepts for all 5 graphs. But then the Y-intercepts are different. So this right here is down here at a -72. Does that mean that -72 is a minimum? No, it does not. Okay. Then on the second one, I'm here at -12, which kind of looks close to my -72, but that's okay. Then I'm at 96. We'll just kind of do it in a fashion where we do a piece at a time. Like an assembly line. So these graphs have some things in common. That's what I want you to see about the assembly line thing. They have some things in common, but in the end, they're going to look pretty different from each other. So when I look at the first one, it is an even one, so I know what my end behavior looks like. Okay, it's going to be both of them up here. And then I know what's happening. Now the point of inflection for myself, I'm trying to draw it. I can't really bring it down and it never looks right. Just remember that what you're thinking about with the graph is what a cubic looks like. That's the fashion you're trying to get there. So at this point, it has to change concavity there. So it needs to be very clear that that's what's happening and not that just you have a shaky line because you can't, draw them straight. So there's my point of inflection. Right? Then it's got to come down. And it's got to cross the -72, but that's not necessarily the minimum, but a lot of times for me it ends up being because of my graphs. Then when I come back up to my next intercept, it's going to cross. And then it's going to have to bounce, because if it doesn't, it comes back down here and my end behavior isn't like what I know it's supposed to be. So it's going to bounce and come up something like that. Right? Everybody okay with that? I know it's not beautiful. Do the best you can. All right, I want you to draw the other ones. Okay, so here's what I got, and I kind of might have missed my points a little bit. I'm just going to go back and make my points a little bit bigger. This should be good. So there's not much of a difference between the last two. That's why making sure that point of inflection really looks like a point of inflection is important. Okay. Any questions on these? You need to be able to draw them. You need to be able to identify what they are from ones, or sketch them, ones that are drawn for you. I know we're not all artists, myself included, but we're good. Any questions on those? Awesome.